Hello, today we're going to be talking about lesson 4.4, which is on proving triangles congruent using the side, 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 and side, angle, side postulates. So first we want to look at the side, side, side postulate, which is postulate 4.1. It says that if I have a triangle in which AB is congruent to DE, BC is congruent to side EF, and AC is congruent to DF, then the triangles would have to be congruent. If all three sides are congruent to all three sides, then the triangles are going to be congruent. So let's look at an example of a flow proof. Okay? So it says, given that GH is congruent to KJ, and HL is congruent to JL, and J is the midpoint, L is the midpoint of JK, so this is the midpoint. It means that this side is going to be congruent to this side. They're going to be equal. That the triangles are going to be congruent. Well, given that GH is congruent to KL, or KJ, we already looked at that. HL is congruent to JL, good. L is the midpoint. That means what we just said, the tick marks, that GL is congruent to KL, according to the midpoint formula. Well, if all three sides are congruent, then the triangles have to be congruent by postulate 4.4, or you can denote this, it's super easy to use SSS, which stands for side, side, side postulate. Alright, let's look at an example of side, side, side on a coordinate plane. Triangle ABC has vertices 1, 1, 0, 3, and 2, 5. Triangle EFG has vertices 1, negative 1, 2, negative 5, and G is 4, negative 4. First part, graph both triangles on the same coordinate plane. Okay, so we have our coordinate plane in our notes. Let's do that. So A is at 1, 1. That's A. B is at 0, 3. And C is at 2, 5. There's C. Okay, so here's my triangle right here. Okay? I'll redraw it real quick, but it's already in your notes. 1, 1, 0, 3, 2, 5, right there. A, B, C. Okay? Now, let's look at EFG. E is at 1, negative 1, 2, negative 5, and G is at 4, negative 4. Alright, well, just by looking at it, part B says, use your graph to make a conjecture on whether the triangles are congruent. From looking at this, I would probably say that the triangles don't look like they're even the same shape. But I'm not quite sure how I can prove that right away. So what I'm going to do is I'm going to say, alright, let's go back to the distance formula. And let's find all three sides of my triangle. So the distance formula, remember, is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So let's first look at AB. Okay, so AB's distance, the length of AB, I'm going to take x2, which is 0, minus x1, which is 1, squared, and 3 minus 1 quantity squared. So that would be the square root of negative 1 squared plus 2 squared, which is going to be the square root of 1 plus 4 equals the square root of 5. Okay? So we found the first one. AB is square root of 5. Let's find BC. Okay? Well, BC's points are B is 0, 3, and C is 2, 5. So it'd be 2 minus 0 squared and 5 minus 3 squared. And so then we'd get 2 squared, 2 squared. Okay, that's 4 plus 4, square root of 8. Alright? Next one, let's look at AC. Okay? Square root of, let's see, 2 minus 1 squared and 5 minus 1 squared. So then that would be 1 squared plus 4 squared, square root of 1 plus 16, which equals the square root of 17. Alright, so now you're probably wondering, why have I found the distance of all three sides? Okay, well that's the distance, that's the length of each one of the sides in triangle ABC. So what we're going to do now is we're going to find the sides of EFG and see if they line up. See if they match. If they match, then I'm good. So EF is 1, negative 1, and F is 2, negative 5. So the square root is going to be 2 minus 1 squared and negative 5 minus 1, negative 1 squared. So that would be 1 squared, and that would be, let's see, negative 5 minus a negative is like adding. So negative 5 plus 1 would be negative 4 squared. Okay, and I'd say 1 plus 16 square root of 17. Hey, check it out. We see that I have the square root of 17 and the square root of 17. That's good. They line up. So let's take the next one. Let's find FG. Okay, well FG, F is 2, negative 5, and G is 4, negative 4. So we're going to take 4 minus 2 squared plus negative 4 minus a negative 5 squared. Okay, well 4 minus 2 is 2 squared, and then 4 minus a negative is like adding, so negative 4 plus 5 would be 1 squared. Okay, so that's 4 plus 1, which is the square root of 5. Hey, check it out. We had square root of 5 and square root of 5. So we need to see then if EG is the square root of negative 8. So let's check that out. So EG. Alright, well, the distance from E to G was 4 minus 1 squared plus negative 4 minus a negative 1 squared. Okay, so then 4 minus 1 is 3 squared. Negative 4 minus a negative is like adding, so negative 4 plus 1 would be negative 3 squared. I get 9 plus 9, the square root of 18. Is that equal to the square root of 8? It's not. So that actually means that these triangles are not congruent. So you would say triangle ABC, congruent sign with a line through it, like not equal, not congruent to triangle EFG. All that work to find out they're not congruent. Here's an example of another one. If you're unsure of yourself, try this one, and you can talk to me about it tomorrow in class. All right, so vocabulary word, an included angle. What's an included angle? Well, an angle formed by two adjacent sides. Let's say I have side AB right here, and I have side BC. This angle right here is called my included angle. The angle formed by two adjacent sides of any polygon. So actually, we have a postulate for 2 which says the side angle side congruence postulate, or side angle side, says that if I have side AB and it's congruent to side DE, and then I have angle B is the same as angle E, and then I have BC is congruent to EF, that my triangles are congruent. The reason that is because this angle right here corresponds with the other side. And so if the angles are congruent, it means that these sides are going to be forced to be congruent. And that way, our triangles are congruent again because all three sides are the same, and then all three angles are going to be the same. So let's look at this example right here. We have a proof. It says the scaffolding for stage lighting appears to be made up of congruent triangles. If WX is congruent to YZ and WX is parallel to side YZ, write a two-column proof to prove that the triangles are congruent. Alright, so the first thing we see is that in our proof we have WX is congruent to YZ. Well, that's just our given information. Okay? Then it says WX is parallel to YZ. Same thing, given information. Now, it says that angle WXZ, that would be WXZ right there, is going to be congruent to XZY. Now, why would those be congruent? Well, since we know that WX is parallel to YZ, and there's this transversal that cuts it in the middle, those two angles are alternating interior angles. So alternating interior angles are going to be congruent. Also, it says that side XZ is congruent to ZX. So that's not the reflexive. Reflexive it would be XZ is congruent to XZ. But since it's just the opposite, that's called the symmetric property of congruence. And so then if we look right here, we now have, I'll color it in purple for you so you can see it better. WX is congruent to YZ. These angles are congruent, and this side is congruent to this side. So we now have a side angle side congruence. Very good. All right, last example right here. Says this, write a paragraph proof. Given that BC is congruent to DC, that these angles are congruent right here, and that FC is congruent to EC, prove that this angle right here, FCD, or CFD, excuse me, CFD, is congruent to CEB, this one right here. Alright, so first, our proof, it would say that since BC is congruent to DC, angle BCF is congruent to angle DCE, and FC is congruent to EC by side angle side triangle BCF is congruent to triangle DCE. Okay? So that helps us out. Now we know that those triangles are congruent. Okay? Now what we can also say is that since these triangles are congruent, these sides right here are going to have to be congruent as well by the congruent polygon parts. So we're going to say that angle CFB is congruent to angle CED by congruent parts theorem. And then angle CFD is going to be congruent to CEB by linear pairs and congruence. Box it, we're done.